All right, so I'll do one quick overview. Forgot to record, so I'll do one quick overview of that again. Okay. So I'm going to read in the data files that have been provided to you. And then the goal here is to find the hour during the day where the animal is moving around the most. And we're going to use the standard deviation of the magnitude of the accelerometer data to represent the most active hour. And this is what we're plotting down here. So the animals wake up in the morning, they go to the trough, they eat, so they're moving around a lot. So the standard deviation is high here. And we didn't collect data during the midday because they stopped moving around actually a lot. And then at 8 p.m., we started collecting the data again. So there's no data actually in this time between about 7 or 8 a.m. to 8 p.m. And this second plot is the histogram of the most active hour. So this is the accelerometer magnitude and around, basically what is the value of that and the counts of that magnitude, okay? All right, so that's the goal. And also, if you don't do this right, it can take a long time. So you need to optimize your code, use the time functions that we've talked about earlier, minimize the loops, use vectorization. That's the power of NumPy and Python, is that you can do vectorization. So try to minimize loops, okay? All right, so let me give you some hints on how to do this. Here's some code. Let's see. All right, so I've defined my variables here. And then I use this function called read PPG files, or I think you may have created a different function because this is a custom function that I made. I may have called it read data files in the file that you can download. So there's source code to this that you could use, or you could use your own function. Okay, so that's available in one of the modules, and you give it the file prefix, the start file, and the end file. So read file 6 to 163, because we're reading all of them because we want to find the most active hour over all of the data sets. I've got two ways that I have done this. Here's the slow way, and you can sit in a loop and then you can interrogate the pandas data frame called data and look in the time column and then convert that into this human readable time data. And that's what this function does right here. And I have a whole video on how to do this. I'm going to ask you to go watch the video. And maybe I'll ask a question, what is in the data file that's saved to disk in the time column right now? Can anybody answer that? What type of data is it? Is it an integer, float, timestamp, in this column called time? Let's go see what that looks like. Victoria, you have a guess?
Is it like a timestamp or float?
It is, let's look at it here. So what's weird is this integer value. That integer value is a standard that's used in the computing industry, and it's the number of seconds counted since January 1st, 1970, okay? So that's what that number represents. But it's not human readable, right? So we have to convert that into a human readable form, and that's what this function does right here, okay? Now, and that's called Unix time. If you went off and said, convert from Unix time to human readable form, you would come across this module up here called, where's it at? Date time in time. So those are the two modules we're going to import and use. So that's what that function does. So once you convert it from that integer, it looks like this data right here. So this data was collected on October 24th, 2019 at what is 2100? That's 11 p.m. Okay. So that's what that function does right there. Now you can sit in a loop or do it. Oh, or there's a built-in function called to_datetime units equals seconds that does in one line of code that converts that whole column of data into human readable code. Okay. So I have a question. So why, this is covered in the videos, so I'm hoping you're watching the videos before you come to lecture, but why is this data the same for 100 samples? Anybody have a guess at that? Why is it exactly the same time? 100, it probably then it switches over eventually to 3 right there, it switches over.
The only thing I can think of is it takes like 100 samples per second.
Bingo. Who said that? That was great. We're collecting data at 100 samples a second, and it's only storing the timestamp every second. So awesome. That's exactly the right answer. So so we're getting 100 of these data points per second. Bingo. Okay, so that's what that does. So that converts this column into human readable time, which looks like this. Okay. Notice how I printed that out. Data.loc 0 through 5 times. So I give you the first 5. Then what I want to do, and this is a little tricky, if I wanted to just get the 11 p.m. data, how would I do that? So if I wanted to get the 11 p.m. data, I can iterate through this time column and say, retrieve me the data for every file that has space 21 in the time column. Does that make sense to you?
Well, in the video, you made a filter, is what you called it.
Yeah.
And then it was like this string of, say, 11.
Right, there it is right there. So here's my filter. And then it contains this string, right? If it's less than 10, right, because it is 0, if it's 9 a.m., it's space 09. And if it's 10 a.m., it's space 10. There's no 0 in the front. So you have to do a little clever thing with this if statement. Okay. And then I make the filter that says, oh, I want any time that contains this hour. And then, oh, retrieve, using this filter, retrieve this set of these columns. Accelerometer X, Y, and Z. Then I calculate the magnitude. So you have to know the equation for magnitude. And so that is NP. Notice NumPy, right? It's faster. NumPy, square of that column plus the square of that column plus the square of that column to the 0.5 power. And then you know what? This probably could be even faster if I use the NumPy square root. So you could improve upon that by not doing that, but use NumPy square root. Can't remember if I tested that in the past. All right. And then you need to calculate the standard deviation. So that's what this does. It's like, okay, take the magnitude for the hour that we're on, calculate the standard deviation. Let me make this a little larger. You guys can see that better. So line 78, return the standard deviation for this hour, stored in this list called m_std. Oh, is it the top one? You could do this afterwards. I did it here. I just said, oh, if it's the top one, store it into this variable called top. And, oh, by the way, there's sometimes we're not collecting any data, like 10 a.m. There's no, so you need a condition to handle that. Oh, If there's nan, if not, a nan is not a number is what that means. If there's a nan, then make that hour equal 0. Bam. All right. So then you plot out your data. So that's pretty cool. I think I've given you a lot of hints for this exercise. And so you guys should be able to finish that up. Okay. Let's see, I did a couple other things here. Let me load this up. Where did I put it? I put it over. No. I have a Jupyter notebook that I've been using. I lost it. Maybe it's over here. There it is. All right. I'm going to walk you through this one more kind of even higher level. Read in the data, but I'm only reading one data file this time. And here's what the time column looks like, right? That's an integer, and that represents the number of counts every second since January 1st, 1970 by convention. That's Unix time, okay? We're going to convert that into human readable time. A little function to do that right here. And it says, oh, I could even go out to milliseconds here too, by the way, but this says return it in seconds because we know we're collecting by seconds because it's the same integer for 100 samples and we're collecting 100 samples a second. Okay, that's how we do that. Here's what the data looks like. Human readable code, that's what's in the time column. I've created my own function called read data files. You guys were supposed to do that in an earlier exercise. I have posted a solution for this, so you can use my solution or yours. And it's basically this function that reads in the data files, given a prefix, start file number, and the end file number. And it basically, there's a couple of techniques to do this. It basically makes a vertically stacked huge data frame of all the data in that 163 files. Some little tricks here. Drop the index because it restarts counting over on the data frame index every time, so we drop it. So you can take a look at this code. This is posted, and you'll have to use that code to read in your files. Okay, so that's what that guy does. So from read data files, the function name that I used is called read data files. Oh, notice how I'm making the constants here. I like to put them all caps with an underscore so I know that those are constants. And I don't like to see hard-coded constants in these functions because you don't know exactly what that function does just by glancing at it. It's better if you have an overview of what the parameter values are. Okay. We've talked about hard-coded constants a couple of times in here. I'm just in pandas here or in Jupyter, and I printed out the data frame. Here's what it looks like. And then once we convert it, this is what the conversion looks like that goes into we're just writing over the integer and putting it in the same column called time. And here's maybe a simpler way of doing this, or maybe it's not simpler. It's just I don't sit in a for loop. I basically say, let's start on the 24th day, and I'm going to start looking at hours 20, which is 10 p.m., 11 p.m., 12. Let's see, what is that? No, it's 8 p.m., 9 p.m., 10 p.m., 11 p.m., and this is the filter. Similar to the example that was in the video. I make a filter of all of the days. I mean, in this case, I'm just using day 0. And it's returned. So this is just another example. If I want to get the day, and then I want to get the filter that looks at the hours, I can pass that in. And now I've got the day at 4 hours. That's what this one does right here. Now notice that this symbol right here is an OR statement. It's basically a bar, and that means OR. Okay, so I want hour 0, which is 8 p.m., 8, 9, 10, or 11 p.m. And I want to return the data for those hours on that specific day. Kind of clever. And then here's the magnitude. And what I did here, and we'll do this later in your example, is I divided by the means. That normalizes it. So I take the mean magnitude value, and then I divide every point by the mean. And so that has everything come out around 1. And so it's easy to look at the data and say, oh, this point right here is 15% greater than the mean value. And what we'll do later on is we'll set a threshold. Anything that goes above 10% of the mean, then we're going to say, don't look at that data because the animal's moving too much. That's the goal of what we're trying to do here. All right. So, there's a plot of the magnitude data. You can see that it's all kind of around 1. I will stop there and see if there's any questions. All right. So let's see, when is this one due? Is it due on Monday, or is it due available from?
I think it's due tomorrow.
That's due tomorrow. So you don't have a lot of time to work on this one. We're kind of moving pretty quick now, but I've given you a good skeleton on how to do this if you've been following along. And I'll post, it takes about 4 hours for this recording to finish. So I'll post by the end of the day the recording, okay? Okay, I hope to have the finals, not the final, but the midterm coding part of the exam finished by Sunday. Looking at those and giving you feedback. I have a little rubric that I grade to, and you'll see that. But here's the thing, and the solution to the coding part of the midterm is already posted. So you can go look at that. When I give you the score, you can go look and see, well, this is actually how I did what I did, and here's how I got points were counted off. Okay. All right, I'm going to stop there and I'll hang out if anybody wants to hang around and have any questions. That's what I had planned for today.
Thank you.
All right,
Thank you,
guys.
Professor.
I have a question. For the multiple, were we supposed to always submit the Google form, right? We didn't have to take a screen capture or anything.
You kind of dropped out there, Alyssa. Here's what I heard is the multiple choice, you didn't have to take a screen capture. Yeah, you just had to answer the questions.
Just to make sure, because it says not submitted for me on Canvas.
Yeah, I haven't posted it. Oh, it does? Huh. Yeah, you haven't submitted it. You just filled out the form. I haven't released the scores yet on Canvas. So you're good.
Okay, thank you.
All right, take care.